in this question, we are given that n is a positive integer and it is the product of all integers from 1 to n. That means n is equal to 1 times 2 times 3 till n. Now if you can recall, this expression is the expansion of a factorial of a number. So n factorial equals 1 times 2 times 3 and so on till n. Now this is a multiple of 990. That means n factorial is equal to 990 times k, where k is any integer. We have to find the least possible value of n. Now let's factorize 990 first in step 2. So 990 can be factorized as 2 times 5 times 3 squared times 11 times k. By looking at these factors, we can find the least possible value of n, which we will do in step 3. Now let us consider few cases before we arrive at the final answer. Let's take n to be equal to 2. Now when n is equal to 2, 2 factorial is equal to. Now this is not a multiple of 990. Similarly, when we take n is equal to 5, 5 factorial equals 5 times 4 times 3 times 2 times 1. Now this cannot be a multiple of 990 because it contains only 5, 4, 3 and 2. It should also contain 3 squared, which is 9, and 11. So n is equal to 5 is not an option. Hence, if we take the value of n to be equal to 9, then 9 factorial will be 9 times, 8 times, 7 times and so on till 1. Now again, this will not be a multiple of 990 because 11 is still not included. So the least possible value of n that we can take such that it is a multiple of 990 is when n is equal to 11. Hence, n is equal to 11 is the least possible value of n, which is the option D.